Hey guys, this is Sam Gabriel, and today I'm excited to share a demo with you about infrastructure as code, how we can deploy an application to Azure Cloud using Terraform Enterprise. I'll have another video on AWS and maybe another one on Google Cloud, but basically we're going to go through the workflow, how you can connect your version control system with Terraform Enterprise, and when you commit your Terraform code into your version control system, such as GitHub, that will automatically trigger a run inside of Terraform Enterprise that will go through a series of checks. Some of those checks are policy as code checks using Sentinel that will basically make sure that you're allowed to deploy these artifacts as they are. So this is your governance, if you will. This will be your guardrails to make sure that you're allowed to do what you're just about to do. So let's go ahead and take a look at the demo. All right, so let's get started. I want to just share a few slides here to explain briefly how Terraform works in case we have folks that don't know. Let me just move myself here at the top a little bit, get a bit bigger. All righty. So a little bit about the workflow and how Terraform works at a high level. So if you have user A and user B, they're both committing Terraform code into a version control system. And the ultimate goal is to create some resources in your cloud. Terraform runs somewhere in the middle here. It could be Terraform Enterprise that lives in your own environment, behind your own firewall, or it could be Terraform Cloud, our SaaS offering. And there is a connection that you will have between your Terraform Enterprise, and the version control system that you're using. Of course, you're going to have different repos inside of GitHub, GitLab, Bitbucket, and so on. These repositories map to what we call workspaces inside of Terraform. And typically a workspace, depending on your organization, but you can have one workspace per project, one workspace per application. And again, it ties into a certain repo, and it ties into certain artifacts or certain infrastructure that you want to deploy. Each workspace has its own state file that lives inside that workspace. And a state file is really what Terraform sees the real world as. So if you've deployed maybe 2 VMs in Azure, then your state file would contain those 2 VMs. If you increase that to, let's say, 5 VMs, then Terraform understands that you want to add 3 more, and it'll go ahead and do that and keep that state file in a safe place inside of Terraform Enterprise or Terraform Cloud, which is very important because state files can or might contain some sensitive information that you don't want to have sitting in some developer's local machine. You also have credentials and variables that you can identify and you can define actually and specify inside of Terraform. And we'll see in the demo that these can be secrets that are very sensitive, and you can have them as write only. So once you write them, you can't retrieve them. In addition to that, we have our Sentinel Policy engine that will run before anything gets applied or deployed into your infrastructure, which is very important. You don't want to run policies after the fact. You want to be able to do it beforehand. So the policy could allow you to deploy your infrastructure. It could be what we call soft mandatory. That means you need to override it with somebody who has privileges to override it. Or it could be a hard deny, basically, that will not allow you to deploy anything. Then we have what we call a private module registry. And here, this is really excellent when you want to move to more of a self-service model, and you want to move from just specific people that know how to use Terraform into a producer-consumer model. We'll talk about that in just a bit. But basically, again, you tie your repos in your version control system, which is always a source of truth, into the different modules. So you're breaking up your big Terraform code into different modules, and that each module can deploy certain resources or certain services in your cloud, such as load balancers, DNS, and so on. So that's a high level of what it looks like. Let's go dig deeper into what a typical team adoption looks like. So in the very beginning, for individuals, Terraform open source is quite suitable, where you have an individual contributor that wants to run Terraform and run the plan, run the apply, and deploy the infrastructure, and ultimately continuously uh, do that. You have the state file that runs on the user's machine, but then you move into teams where you want to be careful not to step on anybody's toes. You don't want to have different people configuring the same environment. So what you do is you configure everything and you commit it to your version control system. You do your plan, you do your apply, and then you continue down the cycle. But now you have one source of truth, which is your version control system. Next, you move into multiple teams, and at this point, you have network teams, logging teams, monitoring team, databases, application teams. Each one of those teams have their own Terraform configuration files. Now things get a little bit more complicated, and you need to have some checks and balances. You need to run some RBAC. You don't want an application team to mess around with your network, so your network would probably run a read-only access control. Then you move into an organization with many, many users, right? At this point, like I mentioned earlier, we want to move into a publishers consumers model where publishers understand what Terraform is all about and how to run it, and they know how to write the code. So then they will write the modules into a module registry, which could be a private or could be public. There is a public registry out there, but obviously for your organization, you want a private one. So you write those modules, and then consumers just look at the module as a black box, and there's inputs and outputs, and basically they consume that without necessarily understanding what the Terraform code is. In addition to all that is the concept of policy as code using Sentinel. Again, the checks and balances of what you're allowed to do. So if something like a VM that's bigger than the size that you've put in the policy, maybe the cost is too much, then you can deny that. So let's talk about the workflow. First, we're going to talk about the version control system workflow, and then we're going to talk about CI/CD workflow. So version control system, first you have your VCS repo in GitHub, for example. You get Bob, deploying his Terraform code with modules and inputs. That gets generates a plan in Terraform Enterprise. You have audits that go to a SIM. Sentinel policies kick in. This is at the plan, right after the plan phase, without deploying anything into production yet. So if the Sentinel policies check and pass, then you move to the apply phase, where you apply the infrastructure into your cloud or data center. So what we talked about here is the Sentinel policy, the private module registry, your VCS control, secure remote state, and also your auditing. Finally, the last or the second workflow that you can apply is with CI/CD. So in this case, once again, Bob pushes his code into GitHub, but at this point, GitHub is not connected directly to Terraform Enterprise. It goes through your CI/CD workflow, whether that be Jenkins or Circle CI, whatever you're using for CI/CD. And then once a build happens, your CI/CD tool will talk to Terraform Enterprise through the REST API or through the Terraform CLI that could be running on your Jenkins system, for example. From there, once again, the steps are the same at this point. You plan, you go through your Sentinel policies, you apply, and you're good to go. So the only difference here really is in the CI/CD pipeline stage here, where it's one extra step along the way. Okay, so let's move into the demo. So what I'd like to do before we dig into this, I want to show you, first of all, I've got my Azure console, and I'm going to run a resource called SAMG. I'm going to just prefix it with SAMG. I'm just showing you that there's nothing really, no resource groups running at this point. So my infrastructure is quite clean. Nothing is running. And I'm just going to quickly walk you through the UI of Terraform Enterprise or Terraform Cloud, just to give you a feel of how things are organized around here. The first piece is what we call the organization. You can be a member of multiple organizations. An organization could be a whole entire department, or could be the entire organization that you're part of. And the next piece here is what we call workspaces, and we talked about that earlier. Usually a workspace maps to a repo. And then we have modules, and we'll dig into that later on in the demo. But let's quickly take a look at the settings menus that we have here. So you can define, of course, users, and you can define teams and give access to what different teams can do. So your ops team can probably manage your policies, the Sentinel policies for governance over here. You might not want your devs team to be able to change that. Ops team can manage workspaces, your VCS settings as well. And you can add team members into here as well. VCS providers, we have multiple of those that you can define. Of course, GitHub.com, Enterprise, GitLab, Bitbucket, Azure DevOps, and so on. We have two-factor authentication that you can turn on as well. We have cost estimation turned on, which we'll see in later in the demo, how that works. And then policy sets, this is where you define your Sentinel policy for policy as code. You can see one is defined here, TFE policy. You can tie this, or you actually do tie this to your repository. In this case, I have this TFE policy that lives in GitHub that's tied into Terraform Enterprise here. Now, the scope of the policies, you can apply this to every workspace in your organization, or you can select specific workspaces. In my case here, I've selected that this TFE policy will only apply to the workspace called HashiCat Azure, and that's what we're going to be running shortly in the demo. All right, cool. So let's move to the next section of the demo. And here, let's move over to our workspace called HashiCat Azure. And let's talk about variables for a minute. So these variables can be defined locally in your own environment, on your own desktop, and we'll talk about the different methods of running or utilizing Terraform Enterprise. You can use the CLI and use Terraform Enterprise as your backend, or you can use Terraform Enterprise or Terraform Cloud to host almost everything and connect directly to your VCS. So in this case, I'm looking at some of the variables I have in this workspace. I got my prefix SAMG, and that's what I showed earlier within Azure. Nothing's been deployed yet. This is to be able to have everything contained in one resource group, to be able to find it later. And then here you get the placeholder. In this case, we're gonna show an application that shows some cats on the screen. You can change that, and we'll change that later. So these are just basically some of the variables that we're running here. Also, environment variables, this is where you want to have the, since we're running Terraform Cloud or Terraform Enterprise, you need the environment variables there because that's what's going to go out and connect to Azure. So here are all the different environment variables that I need to connect to Azure. If you notice, ARM client secret is sensitive, so you can't see it. So if you add a variable, you can always check this, and this will be a sensitive write only, which is very handy so people can't see some of your secrets here. All right, cool. Okay, so now let's take a quick look at the the way my files are configured here. As you can see, I've got my main Terraform file, and this is where it defines my provider as Azure, and I have different resources that we're going to build in Azure. I have an output file that will give me the URL of the application so we can go to it, and I've also defined a variables file which tells me, or tells Terraform, what the defaults are. So you declare the variables here, and then you define them in you define them here, and then you can apply them or declare them inside of Azure Cloud or Terraform Cloud or Terraform Enterprise directly. Okay, so at this point, we can do a couple of things. I can run a manual, queue the plan manually. So say first run, and let's queue the plan. When I do this, since all my Terraform files are connected to through the version control system directly to Terraform Enterprise, it's going to go and pull those files directly from GitHub. It's going to run the plan, and then you can see the next stage is the cost estimation, which will automatically move to it after it's done. Let's expand this a little bit to see what we're deploying. You can see we're deploying a network, deploying security groups. Looks like it moved to the next section. Let's just expand it one more time. You can see some public IP that's being deployed. This is the resource group that we talked about. Subnet. Here's the VM with all the specs for the VM, and so on. Okay. All right, as you can see, it's now calculating the cost. So that's the next step. Okay, so it finished calculating the cost, and you can see that my hourly cost for this build is 6 cents per hour, and it's $43.20 as a monthly cost, giving me a delta of $43.20 because I don't have anything deployed beforehand. Now the policy has failed, and we'll see why in just a second. We've got two policies here, one that says restrict VM size, and the other one restrict cost. So the first one failed. You can see a description here. This policy uses the Sentinel TF plan import to require that all Azure VMs have VM sizes from an allowed list. The list of allowed VM sizes is standard A0. And you'll see I deliberately put the variable for the VM size as standard A1. So we're going to go fix that in just a second. And then the second policy here is called the restrict cost policy. As you can see, it's a soft mandatory. The other one is also soft mandatory, meaning I can go ahead and override it. That's what we'll do in a second. But the description for this one, this policy requires that the delta monthly cost is less than $20. You can see here our cost was 43 something. So of course that's why this failed. This is important to note that you can always add more policies or into your GitHub repo that will that'll get checked right here. I'm going to go ahead and override this policy and say, hey, approved by John in upper management or something. Okay. So I have the privilege to override this, and this could be maybe your security team or maybe your operations team, some team that will look at this and say, hey, are we allowed to deploy this? If so, you can go ahead and override it. Everything is audited, as you can see. And then you're going to apply this into the Azure infrastructure. So it looks good. Go ahead. Okay. So now the apply gets queued. And at this point, we're going to run through and apply the resources into our Azure cloud. So this is going to take a little bit of time. So in the meantime, let's go back and take a look at that policy that we were looking at earlier. So let me pull that over here. Okay, so we had two policies, and you define this in a GitHub repo, as I mentioned earlier. Here are the two policies: the restrict VM size, and the other one's restrict cost. And then you define them here. So the cost one, very simple rule, saying the delta monthly cost is less than 20, and the delta monthly cost is pulling from here. So Sentinel code is, you can look it up on Google. It's very simple to use. I know a lot of out-of-the-box policies that you can just use or tweak. Here's the VM size as well. You can see at the bottom, it gives us the list of allowed VM sizes in here. All right. Let's see how far we've gone. Okay, as it's still deploying. So while it still deploys, let's do this. Let's go back to our workspace, HashiCat Azure. I want to talk a little bit about the settings menu here. So in the workspace, which is this HashiCat Azure workspace, you have two execution modes. I mentioned this really briefly. The remote mode is basically letting Terraform Cloud or Terraform Enterprise go ahead and run everything on your behalf. On the other hand, you can go down the local path execution method and say, hey, I want to use my own CLI to run everything, and I just want Terraform Cloud to sync my state. So at this point, it will contain the state file, and that's it. So it will not trigger on version control or anything like that. There are also two types of applies. There's an auto apply, which is quite dangerous. I do not recommend using it, meaning that if the plan and the policies and the cost of submission, everything checks out fine, it will automatically go out and apply your infrastructure. I definitely would recommend using manual apply, just to make sure that nothing gets applied incorrectly or destroyed and you're not paying attention to what's going on. You can lock a whole workspace so that nobody can run anything. You can, of course, add notifications. You can create different notification channels that we have here, webhooks, Slack, and so on. Run triggers is very interesting. It's still in beta, but the idea is that you can chain workspaces. So you can have one workspace. When it's done, it can call the next workspace and so on. Now, you can also define team access at this level. Remember, we're at the workspace level under the HashiCorp SAM organization. So anything that you define in the organization, you can go down to this level and create something else at the level of the workspace itself from an access perspective. Here's where you define your version control specifically for this workspace that ties into this repo in GitHub. You can trigger on every single run, like if you do anything, if you commit anything in GitHub, it will automatically trigger a run in Terraform. You can also specify specific folder paths that if something changes inside of your version control system, that will trigger the run as opposed to trigger at every point. Actually, I do recommend this. So if you have a Terraform folder inside HashiCat Azure, for example, that way, if you change anything at the root level, it will not necessarily trigger a run, only if you change something inside the Terraform folder itself. And then finally, you can destroy and delete the infrastructure here. So we'll do that later, but let's go ahead and check on our run and see what has happened. You can see the applied has succeeded. So let's go ahead and see what happened here. All right, so the resources 8 were added, 0 changed, 0 destroyed, and it gives me my URL for my application. Let's copy that, open a new tab. Oh, look at that. We have our image world app and an acute kitten right there. So very good. So the application has been deployed. If I go back to my Azure console and look up my workspace once again, let's see what comes up. there you go. CCNG workshop shows up, and I have a bunch of resources that got defined here. Here's my VM, I have an IP, I have a NIC, and so on. So that's excellent. Now, let's go back and take a look at our variables. I want to change this from the kitten one to maybe a dog. So we're going to change our application and see what happens. I also want to remove the standard A1 because it's supposedly not allowed by policy, and use standard A0. That's what our policy allows. Excellent. So that's done. And what I'll do is, instead of running or queuing the plan to run it manually, I'm going to actually use and show you how to use version control to do that. So let's go back here. And looks like I do have, so there's a change in my README file, which is good, that I can use to trigger the, actually, let's take a look at my main file. You can add a space or another carriage return to just make sure that this will actually trigger the run. Let's say updated the README and main.tf. Okay. So we're committing now, and now I'm going to push this to GitHub. Excellent. Now this should automatically trigger a run. So if we go back to our runs, and you can see it already went to planning stage, and here's my commit message. And it gives you, of course, the commit ID and so on. And once again, it's going to go through the plan and figure out what needs to happen if we need to change. So in this case, not much has changed. It's only, actually, that's not true. One needs to be destroyed. Remember, we said that we changed the VM size. Let's expand this a second here. Here you go. You see this? VM size A1 is going now to A0. So that's going to change for us. And of course, the file itself is going to change as well. Now we're in the cost estimation phase. I should check out. Okay, so cost estimation is fine. In this case, we're destroying the A1 VM and creating an A0 VM. Our cost goes down. So you can see here the monthly delta is negative 28.8. Our policies are happy. Both the VM size is allowed, the cost is allowed. It's under $20. It's actually negative, so it's fine. And we're just going to confirm. So we can apply this. Okay. Now while this applies, let's take a look at the states. So this is where the state file itself lives. At this point, and for this run, this was the state file. So you can see, let's expand this a bit. What resources exist right now. Remember, the state file is Terraform's view of the real world. So whatever it sees in Azure right now, this is actually what's there. So you can see the instances here, and so on. And this is important that you were saving the state file here so that nobody steps on anybody's toes, like we mentioned in the workflow. Everything is stored locally, but at the same time, it's local to Terraform Enterprise, that is, and not local to your own machine. All right, let's see the runs. We're still applying. Okay. Now this applies, let me talk about the next section of the demo, which is basically the modules section. And here, let's just pull it up really quick. At the top here, this is where the modules come in. You can add different modules that you've defined. And the modules also tie into your version control system. So by now you should see that it's pretty obvious how the workflow works. Everything integrates to your version control system. That's your single source of truth. Really important concept when it comes to infrastructure as code. And as long as inside your GitHub repo, in my case, you have this defined, the repo is defined as Terraform-provider, and then give it a name, it will show up here. So Terraform Azure RM, and this is the name of that repo. You can select that, confirm your selection. I've already done that, so I'm not going to do it again. You can see the details itself. So here's the source code that lives in my GitHub repo. How to use this in a README. What are the inputs for this module? And what are the outputs? So once again, I, as a developer, don't need to know how this code works. All I need to know is what are the inputs and what are the outputs for this specific web app for containers, right? So here are the inputs that I need. The required inputs are at the top. The optional inputs come at the bottom here. And these are the outputs that I can use. So you'll see that we're going to use the host name to be able to find the URL to go to the application, and some of the resources as well. It gives you quickly how to use this. You can use this module as is, like here. You can change the versions of the module. And if you notice, if I change to 2.2.1, which is what we're going to use, the inputs here actually change because we only have 2 mandatory inputs as opposed to the other 5 that we had. Now, a neat tool here is this configuration designer. And this actually helps you in building your module code. So if I choose version 2.2.1, hit next. Here are the required variables. So just name it whatever, name your app. MG, resource group, maybe call it resource group MG, whatever, true. And you can see it's configured once the 2 required inputs are defined. And from here, you get a preview configuration that you can take this module's configuration you can take directly and use in your code. So if I pull this really quickly here, I want to show you that this is very similar to the code that we're using here. So if you take a look at that, what I'll do is I'll get this code ready. Let's just remove the start from the end. Uncomment this. So now, if you notice the other main Terraform file, it was quite big. In this case, we have just one module that defines a bunch of variables here, and that will go ahead and deploy our app for us. So obviously modules is huge when it comes to a self-service model for your consumers. Okay, let's go ahead and save that. What I'll do is I'm gonna push this. I'm gonna commit it and push it. Let's call this just let's go. So commit that and push it. And it's going to get queued. We only have one concurrent run at this point in Terraform Cloud. So it's going to get ready to run. But let's go back and take a look at our, you see it's starting to run here, HashiCat Azure modules, because the other one is already applied. And since it's applied, let's go ahead and see, just to verify our URL here. Okay, this is still the same app where we had cats, but we changed it to dogs, right? So there you go. It works perfect. I have a picture of a dog now. Now, in the meantime, since we didn't want to waste a whole lot of time, we're already running the other module, the other workspace that's utilizing a module. And this is a different application. I'm going to confirm this is all good. Go ahead. And while it actually runs, let me talk a little bit about what it is. It's an application that will run a kind of like an arcade, and it's not using any VMs in this case. It's using a what do we call it? It's called Azure App Service that uses an app service plan. It's kind of a way to. It's kind of like a PaaS. So you run your application directly on that PaaS, and away you go. You don't have to worry about infrastructure. Okay, so this thing is running. So again, this talks about the different resources that you can use. So the way Terraform works, there's your Terraform core, and then there's your provider. Providers are plugins that basically talk to the API of whatever you're provisioning. So in this case, Azure Cloud. So it's talking to Azure Cloud and telling it, hey, I want to provision an app service. This is the service that you have. I want to provision that. So as an Azure or Microsoft employee, I would write the Terraform provider exposing the different services I have, and that will automatically work with the Terraform core that goes ahead and checks the Terraform configuration files, makes sure everything works, and that gets pushed directly to Azure utilizing this app service. All right. Let's take a look here. All right, looks good. Looks like it applied correctly, and we get the URL at the bottom. Okay. Let's see what this application looks like. Look at that. It's an arcade application. Let's play a game. You can select different games, of course. I haven't tried Frogger. Let's see what that looks like. This is just a little ad that we'll get rid of. Okay, there you go. There's the application. There's Frogger. You can't really play it. It's just kind of like a video. Yeah. Anyway, so this hopefully gives you an overview of how you can use Terraform Enterprise in your workflow to provision your infrastructure. And one last thing I want to show you is the ability to destroy after you've finished maybe testing something, application or something like that. You got to queue the destroy plan. But to do that, just to make sure that you don't do it by accident, you got to have a environment variable called confirm destroy, and you set it to 1. So if you go down to the variables, you can see confirm destroy is 1. This allows us to destroy the environment safely. And just queue the destroy plan. It goes through the same checks as before. And then finally, you confirm that, and it will destroy the plan for you, destroy the infrastructure for you. We won't wait for that, but trust me on that, it's going to destroy everything. So hopefully this has been helpful to give you an overview of how to use infrastructure as code and how to integrate that with your version control system and how the entire workflow runs. Thanks for watching.